Hey guys, and welcome back. This is just going to be a very short video on a couple of things that I didn't quite get to. First and foremost, from the last video we saw that if we take a cross product of two vectors, we actually get a zero vector. So a vector that has no length in any direction is the shortest arrow that you could possibly imagine. And in fact, this happens every time you take a cross product of two vectors. It is always going to be the zero vector. And the zero vector isn't necessarily the number zero, because the number zero doesn't have any coordinates. This has coordinates. It's just zero in every coordinate. So it is still a vector, and it's not the number zero. And the last thing that I really want to touch on is really driving home the fact that when you take dot products, you get numbers, and when you take cross products, you get vectors. So let's look at a couple of things. Let's say that I have vectors u, v, and w, and let's combine them in different ways. So let's say that I take the cross product here and the dot product there, and let's add some parentheses. So the question is, does this make sense? Well, sure, because if I take the cross product of two vectors, this is going to be another vector. And then when I take, so this is a vector, and this is a vector, and I can take the dot product of two vectors, and I can get, this is just going to be a number, a scalar. So everything checks out. Let's do this in another way. Let's say that I take u dot v cross w, and let's say I put the parentheses here. Well, what's going to happen? U dot v, this is a number, and I can't take a number cross a vector. That doesn't make sense. So number cross vector doesn't exist. So we know that we can't actually do this calculation, because I could take the dot product, I could get a number, but then I can't take a number cross a vector. So it's really important to try to keep in mind some of these things. We can add vectors together, so we could say like u plus v, and I could take that, and I could take that cross w. I could take So this is going to be a vector, because if you add two vectors, you get a vector. If you take the cross product of two vectors, you get a vector. So there's all sorts of ways that we can combine these operations. In the same way that you can add numbers and multiply numbers and combine them in different ways, we can combine taking dot products, cross products, adding vectors, subtracting vectors. But it's important to keep in mind when is the result going to be a vector and when is it going to be a number. We can't take a dot product or a cross product of anything but vectors. We can only take sums of vectors. You can't add a number and a vector together. You can multiply a vector by a number, just regular multiplication, not the special dot product or a special cross product. So it's just things to keep in mind with this. Just really, you really want to know what you can and cannot do with vectors. And I'll stop there.